2.2, and we are going to focus on finding the zeros, and actually all of 2.3 is designated to finding zeros as well. But I will guarantee you for today, the ones that are coming out of 2.2, they are all going to be able to be factored or use the quadratic formula in some way, shape, or form. Okay? To find the zeros, if we can factor, we're going to set each factor equal to 0. Right?
Yeah.
If we can, sorry, I'm adjusting this because it's not showing the whole screen. Okay, I think we're okay now. If we can use the quadratic formula, that will give us our solutions also. Sometimes we'll actually need a combination of these. Now, when I say use the quadratic formula, in this class, we did not get to the quadratic in disguise. We're going to start off with that today. A quadratic doesn't actually, quadratic means x squared is your highest power. I'm going to take that a little bit farther and say the quadratic formula can actually help you solve anything that's in this format. And what's in the parentheses could be x squared, x cubed, x to the fourth. It can be anything, not just plain x, which means anything whose power is decreasing by half. Let me write something out. So if you had x squared in here, it would be ax to the fourth. All right? Okay. Ax to the fourth plus bx squared plus c equals 0. That is actually what I call a quadratic in disguise. The quadratic formula applies. Anything where you have the powers decreasing by half. So if you go from power of 6 to power of 3 to power of 0, that's a quadratic in disguise. If you go from power of 8 to power of 4 to power of 0, that's a quadratic in disguise. Did you get the idea? The quadratic formula applies to those problems. Let me write down the quadratic formula on the screen so that you have it. The quadratic formula is x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Now, x, what goes right here, is actually whatever is inside your parentheses. Okay, so I'm going to put a rectangle right here. Whatever you have in that spot actually is what should go right here, and it may not be just plain x. Okay? Let's do one of those. So 2x to the fourth minus 6x squared plus 1 equals 0. We're going to solve this. Okay? Do you see how it's a quadratic in disguise? So we're going to use the quadratic formula. That's the technique for this one. Negative b plus and minus the square root of b squared minus 4ac all over 2a. Just kind of set up a little template for myself there. Okay. b is negative 6, so obviously negative 6 is going to be positive 6. b squared, you're going to square the negative 6, minus 4 times 2 times 1, all over 2 times 2. So that's going to give me 6 plus and minus the square root of 36 minus 8, all over 4. 36 minus 8 gives me 28. 6 plus and minus the square root of 28 all over 4. We can actually simplify that, but first, before we do that, I need to talk with you about what this is equal to. You used to be equal to x. Anybody want to take a stab at what you're equal to this time? X, go ahead, CJ. X squared, very good. An easy way to figure out what your quadratic formula is equal to is look at that middle term, and it's whatever the variable is. Okay, it's the square root of the first one, but it's also whatever is right there. So this is equal to x squared for our problem. Okay?
So it's always the middle one?
That's always the, well, if you put them in decreasing order, it's always the middle term. Yeah, it's always the middle term's variable. So this is actually equal to x squared. What do you mean? Like x to the 6th, x to the 3rd? There, then it wouldn't fit the quadratic formula model. All right. Will what cancel each other out?
Talking about the x squared, square root of the whole
You're going to square root the whole fraction and have to put plus and minus here in a second. Thank you for saying that. Before, say what?
Would there be 2 plus and minuses then?
Okay, so hold on just a second. Yeah, way ahead. All right, so right here, this is equal to x squared. I'm going to get a decimal for the square root of 28, add and subtract 6 and divide by 4. So this is actually 6 plus and minus. The square root of 28 is 5.29, and then all over 4. I'm just going to travel right on up here so I don't have to keep going. If you take 6 plus 5.29, you get 11.29. And I, of course, am keeping the exact answer in my calculator. Okay, I'm not rounding. Divide that by 4, and I'm going to get 2.82. X squared equals 2.82, and x squared equals, if I subtract 5.29 from 6, I get 0.708, divide that by 4, and I get 0.177. Okay, now I need to solve for x in each of these equations. Take the square root, and yes, you're going to have plus and minus on both of them. Okay, so you need to take the square root, and don't forget about needing to put plus and minus on the number side when you do that. Okay, so x equals whatever the square root of 2.82 is, and now I am going to have to round because I didn't keep it. Gives me 1.68. Okay. And x equals square root of 1.77, which is 1.33. And you need plus and minus. So plus and minus 1.68 and plus and minus 1.33. How many zeros do you have for this problem? 4. Good. 4, because there's 2 here and 2 here. Guess what? The degree is 4. Remember, that degree is going to tell you the most number of times that you'll cross the x-axis. You may not cross it that many times, but you won't cross it more than that. Okay? What do you think? Pretty good? Okay. On this one, again, the instructions are find the zeros. This is what I was talking about a minute ago. This is not a quadratic in disguise because you have another x in there. Make sense? All right. So we need to employ some other techniques here. Let's think about this. Remember, go ahead. Factoring x out is a great idea. Y equals x times, that'll give me x to the 4th plus x squared minus 6. That's a quadratic in disguise. I could use the quadratic formula on it, but it might be just factorable. That might be easier. Okay, so y equals x times, does this thing factor? X squared plus 3, x squared minus 2, right? Factors of 6 that subtract to be 1. Good work. Okay, I'm trying to solve this thing, so let's set that equal to 0. Now that you have it factored, set each of those factors equal to 0. So 0 equals x. 0 equals x squared plus 3. 0 equals x squared minus 2. I think there's some questions happening about why is it x squared here in the front. What's your answer to that question? Why is it x squared right here and right here? But
Because you have to multiply to get x to the 4th.
because you have to multiply to get x to the 4th, how do you know it's not x cubed and x? How do you know that these shouldn't be x cubed and x to the 1st? Those multiply to be x to the 4th.
Then I don't get x squared.
Good. When you do your inners and outers, you're only supposed to get x squared. You're not supposed to get any x cubes or x to the 1st. Very good. Okay, so your first terms in your groups have to be x squared. All right, folks, how do we solve these problems? X equals 0 is one of my zeros. How do I solve x squared plus 3 equals 0? Yeah, how? Okay, subtract 3 from each side and then square root. And when you square root, you'll have to put plus and minus. So you'll get plus and minus the square root of negative 3 equals x. Okay, you get I involved. Some of you have a good memory. You're remembering from Algebra 2. I did not teach you about imaginary numbers yet. I'm not expecting you to remember those. We will get to go over them, I think, even in this chapter. However, those will not appear on the x-axis. So for right now, I'm going to draw a cloud around those zeros because they are zeros. If I plug in the square root of 3i up here for x, or negative square root of 3i, I'll actually get 0 out. But those won't be places that I cross the x-axis. They're just kind of off on the cloud. We don't know where they are. You deal with the cloud all the time. Okay, you save stuff to the cloud. So these numbers are on the cloud. We don't know where they are. They're not on the x-axis. That's important. They're not in the two-dimensional. They're not in the two-dimensional coordinate plane. Okay? Right here, can I solve that one? Yep. So you should get plus and minus the square root of 2 for these solutions. And those are not nice numbers. It's 1.414 and negative 1.414, but they are on the x-axis. They do appear, they're just not at full numbers. So how many, this is a tricky question, how many x-intercepts do you have? How many x-intercepts do you have? You have 5 solutions. 1, 2, 3, 4, 5. 5 solutions. But you only have 3 x-intercepts because you do not see these 2 right here. They're not real. They're not on the real number system, so they're not on the x-axis. All right? So what do you put for the final answer? Well, it's kind of how it's worded. Finding the zeros means find all the ones that make the equation equal 0. So you would list all 5 of these answers. And if you chose to put I times the square root of 3, that'd be okay. All right? If you want to do I, it's more proper to do that. But we haven't talked about imaginary numbers. I'm not expecting you to know it. Understand so far?
Yeah.
So far, so good? If you can factor something out, do it. You'd be surprised how many times I see people forget to factor out what's in common first. Yeah.
Do you want us to write that like actual square root of 2? Or
No,
can
you
we
can leave it like that. Yep. All right. On this one, is there anything in common that I can factor out? The instructions are the same, find the zeros. Okay? Haven't changed the instructions. That's the only task for today. Can you factor something out of everything? I can't. So, and this is not a quadratic in disguise. That's pretty plain. There's not 3 terms. There's 4 terms. So what we're going to do here is actually something called grouping. Okay, and grouping is one of those things that you want to keep in your math nerd bag of tricks as a factoring technique to employ when I see that I have something in common with a couple of these terms. Okay, you don't even have to have an even number of terms to do this. This can work when you have an odd number of terms as well, like 5 terms. Sometimes grouping is still the technique that works. If there's nothing you can factor out of everything, and it's not a quadratic in disguise, and grouping doesn't work, then you have to do what we're going to do on Thursday. Okay? And it's a long process. You want to try these things first. All right? So for grouping, let me show you how that works. Nothing in common with all of them, but if I take the first two, they share something, don't they? X squared. They share x squared, so take x squared out of both of them. And you're left with x minus 4. Your goal in grouping is to get the same factor in each term. So I either want an x squared or an x minus 4. So now, look at the second two terms. What should you factor out?
25.
I heard two answers. Negative 25 is a better option, and I'll show you why. If you take out minus 25, you're left with positive x for the first term. What are you left with for the second term? Minus 4, and that's really pretty magical because now you have an x minus 4 in each of the terms. Terms are things that are added or subtracted together. So I have this term, the black one, and I have this term, the red one. And they each have an x minus 4. So what you're going to do is you're going to take that x minus 4 out in front of the entire group and let them share it. And you'll be left with x squared from the first term and minus 25 from the second term. And I should have written that in black and in red. All right. And this thing is supposed to be set equal to 0. That was the goal. Okay. Now, you have two options here. This actually, x squared minus 25, anytime you have a power greater than 1 on your x, that could actually factor further. Okay. So you always want to kind of question that. This one does factor further. If I look back at these don't factor further, do they? Okay. So let's try to factor x squared minus 25. If I factor it all the way, I get x minus 5, x plus 5. Okay, so what are my solutions? X equals 4, x equals 5, and x equals negative 5. Very good. Hey, by the way, I'm just going to throw this out there because you're going to need this in section 3 anyway. This is one of the tasks in section 3. We're on section 2, so this is a future task, but here you go. The difference between this factor and this factor is that this one is not linear. Linear means x to the first is your highest power. These factors are all linear, so if I ask you to write the polynomial as a product of linear factors, sometimes by factoring you can get there. If you can't get there by factoring, you can always get there by writing the linear factors that go with the zeros, like we did yesterday. Okay, so when I asked you to come up with the polynomial from the zeros, that was trying to lead you to be able to find the product of linear factors that makes the original. Okay, I'm just throwing that out there. So, three solving techniques really: a quadratic in disguise, grouping, and factoring something out of everything. If those fail, you got to do what we're going to do Thursday. Got it?
Yep.
On these problems, you're only finding the zeros. There are more instructions than just that. If you want to graph them on Desmos, go for it. But I'm only interested in you finding the zeros on 33 to 44.
This added on to the last
You can add it on to the last assignment. I don't really want more than 2 assignments per section, unless it's a really big section. This was not. It just happened that I ran out of time yesterday to do this with you effectively. Okay? So yeah, you can add this on. And don't forget, you have a choice on the last section as to whether you do, was it 55 or 59 through 64? I don't care on those ones. Okay?
Keeps us high.